Okay, I'm hiding in my closet again, and this time I'm racing against the bell because it is now 7:35 a.m. That means I'm trying to make a video in 15 minutes or less about solving logs. Okay, so we've talked about properties of logs. Here's one that we didn't necessarily talk about, but it's called same base property. If I have b to the x and it's equal to b to the y, then x has to equal y. And the other one is if I have a log with a base of b of x and a log with a base of b equal to y, then x has to equal y again, right? So there are a bunch of different methods for solving logs, and there's more than one way to do things. When you're solving a log, the method that you choose is going to be what's going to be easiest is dependent on what you're given. So here I have something that may or may not require an actual log, because if you look here, I do have a variable in my exponent, but both of my bases are powers of 3, so I can go ahead and change this and use the same base property. 9 is 3 squared to the 8 minus x, and then 27 is 3 cubed to the x minus 3. So I can go ahead and multiply because I have an exponent raised to a power, and I get 3 to the 16 minus 2x equals 3 to the 3x minus 9. Here's where that same base property comes in. I have a base of 3 here and a base of 3 here, nothing else other than the exponent. That means that my exponent is equal to each other. So 16 minus 2x equals 3x minus 9. And I go ahead and solve that like any other equation. If I add 2x to both sides, I get 5x equals 25. That means that x is equal to 5. Here's one for you to try. Pause the video, restart it when you're ready, and we'll check your answer. Okay, as you can see, 16 and 8 are both powers of 2. 16 is 2 to the 4th to the 3x, and 8 is 2 to the 3rd to the x plus 6. So go ahead and multiply out your exponents. So we get 2 to the 12x is equal to 2 to the 3x plus 18. Same base here. Those can go ahead and cancel out. That has to be that 12x equals 3x plus 18. When I go ahead and solve for that, I get 9x equals 18, which means that x is equal to 2. Okay, we've already used the change of base formula before. The change of base formula, if I have log base b of x, I can change the base of this to any base, and it's log of a, which is usually, oops, how dare they interrupt me. Okay, so usually we change it to base 10 or the natural log because we want to use it in our calculator. All right, so here I have 4 to the x minus 1 equals 5. If I use, I'm going to take a log of both sides. So I have the log of 4, this is base 10, to the x minus 1 equals the log of 5. I have to do both sides of my equation. That means that I have an exponent now. It's raised to a power. That comes down and gets multiplied. So I have x minus 1 times the log of 4 equals the log of 5. Log of 4 and the log of 5 are numbers. The log by itself isn't a number, but the log of 4 and the log of 5 are numbers. That means I can go ahead and divide all of this side of my equation by the log of 4, and that's going to get rid of the log on that side of my equation. So then I'm left with x minus 1 equals the log of 5 divided by the log of 4. And x is equal to the log of 5 divided by the log of 4 plus 1. When I put that into a calculator, you have to be careful. You can do this in multiple steps if you need to, but I end up with x is about 2.16. And if you're wondering, I'm going to be looking for 3 sig figs. I'm also going to be looking for you to round at the very end and not in the middle of the problem, because exponentials and logs are also sensitive to rounding. All right, so here's one for you to try. 5 to the 5x minus 6 equals 50. Pause the video, restart it when you're ready to check your answer. All right, solving this, we're going to take the log of both sides. The log of 5 to the 5x minus 6 equals the log of 50. 5x minus 6 is my exponent, and it comes down and gets multiplied by the log of 5. And then I'm going to divide both sides by the log of 5 because it's a number. All right, and then I'm left with 5x minus 6 equals the log of 50 divided by the log of 5. And if I go ahead and add 6 to both sides, and then I divide both sides by 5, I should get x is about 1.69. Okay, here's another technique you might need to use. I have the log with the base of 5 of x to the 4th equals 8. Well, I need some way of getting rid of this log here. This is my problem. And so I'm going to use the inverse property. So I'm going to give both sides of my equation a base of 5. All right, and that's going to cancel out the log base 5. So I actually end up with x to the 4th is equal to 5 to the 8th. And then if I want to isolate x, I'm going to raise it to the 1/4. And that leaves me with x equals 8 times 1/4 is 2, so x is equal to 25. See how I did that? I didn't even need a calculator because I didn't try to evaluate it until I was all done. Here's one for you to try. Pause the video, restart it when you're ready. Okay, so I have log with a base of 6. I'm going to go ahead and give both sides of my equation an exponential base of 6 because that's the inverse of a log. And that is going to be equal to 1, so 2x minus 1 is equal to 1 over 6. If I add 1 to both sides, that's 1 and 1/6, which is the same as 7 over 6. And then when I divide by 2, I get 7 over 12. Okay, here's another property of logs that we've already worked with. I have addition here. That means that that is the same as multiplication. So I end up with x times x plus 1 if I combine these logs. And then I need to get rid of the log with a base of 12. And so I'm going to, you guessed it, give both sides a base of 12, an exponential base of 12. And that leaves me with x times x plus 1 equals 12. So x squared plus x minus 12 would equal 0. And if I go ahead and factor that, I get x plus 4 times x minus 3. And when I solve that, shoot, I didn't make the bell. Oh well. I get x equal to -4 or +3. The only solution I can have in this case is +3 because I can't take the log of a negative number. So if I tried to plug in -4 back into the original equation, I'd get an error. So +3 is my only solution. All right, here's one for you to try. Pause the video, restart it when you're ready. All right, again, I have two separate logs subtracted. Their subtraction, that is the same as division. Because they have the same base, I can go ahead and combine them, and I get log base 4 of 100. And since it's subtraction, it's going to be x plus 1 equals 1. And then I can go ahead and give both sides a base of 4. So 4 to the log base 4 of 100 over x plus 1 is equal to 4 to the first power. This is 1, so I'm left with 100 over x plus 1 equals 4. Okay, and now I can, this is a ratio, right, 4 over 1. I can go ahead and cross multiply, and I get 100 is equal to 4x plus 4. And solving that, I get 96 equals 4x. So x in this case is equal to 24. Here's another one to try. Okay, I have log base 5. If I give both sides a base of 5, an exponential base of 5, I get 4x minus 5 squared equals 5 to the 6th. Whoops, forgot my base. Okay, and then if I take the square root of both sides, 4x minus 5 is equal to the 1/2 is equal to 5 to the 6th to the 1/2, which means that 4x minus 5, because my 1/2 and 2 cancel each other out, is equal to 5 to the 3rd. So 4x minus 5 is equal to 125. Add 5 to both sides, and 4x is equal to 130. Divide by 4, and x is equal to 32.5. Simple. Okay, here's the last one for you to try. I have log base 5x, log base 10 of 5x plus log base 10 of 2 equals 10. I'm going to combine these with multiplication, and I get log of 10x is equal to 10. I'm going to give both sides a base of 10. 10 to the log base 10 of 10x equals 10 to the 10th, and then these are going to cancel out, and I get 10x is equal to 10 to the 10th power, and when I divide both sides by 10, I have 10 to the 9th. Right, I subtract my exponents because the base is the same. So x is equal to 10 to the 9th. Wow, that's a really big number. All right, that's it for today. Good luck in class tomorrow solving.